So the last topic of the day, blessedly, is going to be piecewise functions. So piecewise functions are super fun. Not, I'm just saying that because I'm tired. And I'm trying to make it sound more exciting than it is, so I want to do it. I probably shouldn't say that. All right, you're going to have something that looks like this. All right, this is a piecewise function. That means that, you know what? It's true. I really do love this. No matter how hard life gets, I'll always have piecewise functions. All right, is that better? Okay. Basically, the idea is you've got two different options. This function can't make up its mind. What it's doing. Come back, function. All right, there we go. All right, so let's try to figure out what all these various things are. Let's try f of -2, f of -1, f of 0, f of 1, f of 2, f of 3, and f of 4. And that's because I'm crazy. Okay? And I'm going to move these over a little bit because I do want a little room to mess around. Okay. So let's take a look. So f at -2. Remember, these are all going to be your x values. So in this case, x is -2. So what you want to do is you want to take a look here, and you want to take a look here. So given these two options, where does x equals -2 fall in? Does it fall into here, in the first one, or the second? Where is x equals -2? Which one does it match? It's going to match this one right here, because -2 is less than or equal to 1. Okay? Okay, so -2 is less than 1, so this is the one we're going to go with. Let me get rid of all my junk. Okay. All right, so since that's the one we're going to go with, really, you can pretend this doesn't exist at all. All right, so this is the only thing that we're messing with. So we're messing with, I'm going to write it over here. We're going with x plus 2 on this guy. So instead of everywhere we see an x, since x is -2, everywhere we see an x, I'm going to put a -2 plus 2 equals 0. Good? So now look here at this next one. X is -1. So where does this fall in? So you look at the two options, you say, okay, -1 is, again, going to fall into this first category, right? Because -1 is less than or equal to 1. And again, we're going to pretend that this guy doesn't exist. Okay? And that means over here, I'm still using the x plus 2 option. Okay? So where x is equal to -1, where I see an x, I put a -1 plus 2. So that's going to equal 1. All right, and I keep going. Here x is 0. So again, this is going to fit into this first one because 0 is less than or equal to 1. Okay, so I'm still going to be using the x plus 2 option. X is 0 plus 2 is 1. Now take a look at this one here. So if x is 1, which one of these am I going to be using? If x is equal to 1. Hopefully you said this one. If x is equal to 1, because this is less than or equal to 1. So if x is equal to 1, we're going to stay over there. Go away. We're going to stay over there in this first section one more time. 1 plus 2 is 3. And I just realized I added 0 and 2 and got 1. How about that? Okay, much better? Okay, so now let's look at the next one. X equals 2. So now which one of these are we going to be looking at? Hopefully you say this one, right? Because 2 is greater than 1. So it's going to look a little weird, but really there's no x involved at all. The only part of this function that's anything is just 4. So that means when f is negative 2, or when x is 2, f of 2 is going to give us 4. Got it? So what happens when x is 3? Which section are we going to be in? Again, we're going to be in the second section because 3 is greater than 1. So we're still in the 4 section. So that means f of 3 is 4. And just for completeness, what happens when x is 4? We're still in this one. So we're in the 4. So that means 4. All right. Kind of get started on piecewise functions? Okay. What was I going to say? This is what I was going to say. All right, so now we're going to graph this thing. You say, yay! All right. So here, let's make some coordinate pairs. Here, x is negative 2. Remember, f of x is the same thing as y. F of x, the same thing as y. So that's our x. That's our y. So this is our x. This is our y. 2, 0. So see if you can fill in what the rest of these points are going to be that we're going to plot. Okay. See if you can get that. So the next point here is going to be negative 1, 1. 0, 2. 1, 3. 2, 4. 3, 4. And 4, 4. Okay. And I'm going to copy this down here so I can still see it. I'm just going to make a little. It's a little function. So cute. All right. Enough of this nonsense. Let's see what we can do here. All right, so we said we've got a point over here at negative 2, 0. We've got a point at negative 1, 1. We've got a point at 0, 2. We've got a point at 1, 3. We've got a point at 2, 4. 2, 4. We've got a point at 3, 4, and 4, 4. All right. Let me try to line these up a little better. 3, 4, and 4, 4. Now here's the deal. Avoid doing this. All right? Don't do that. Bad, bad answer. The reason for it is this. This is not a single line function. Most piecewise functions are not going to be single line functions. There's going to be something kind of going on here. All right? So what you want to do is you want to investigate a little bit more about what's going on here. So we have a transition point, right? We talked about that way, way long time ago. Let me show you an example. We're talking about. All the way up here, we have this transition point, right? Something is changing. The function here looks different than the function here. We talked about that being a transition point. So that's what we're looking at here. We've got a transition point. So x equals 1 is a transition point. All right, so what that means is before, so this is my x equals 1 right here, right? That means that anything before that we can be really confident in. Anything before that. Because this was x is less than or equal to 1. So anything where x is less than or equal to 1, we're pretty confident that we got that going on. All right. The other part is x is greater than 1, and we only investigated this, so we're pretty confident and everything over there is right. But the question is what's going on right here? What's going on in between those 2 points? Okay, so the way we need to figure this out is we have to investigate. So what if I asked you for f of 1.5? So if I asked you for f of 1.5, go in here and say, okay, well, x is 1.5. So if I look up here in my function, that means I'm in the second half. Oops, I'm in the second part. So that means I'm in the 4 section. So f of 1.5 is 4. So the point would be 1.5, 4. So I can go 1.5, 4. I'm going to have to erase this and figure out what's going on. So 1.5, 4. What is f of 1.1? All right, you're still in the same position. If x is 1.1, you're still greater than 1. So that means you're over here in the 4. So I'm in the 4. So I've got a point of 1.1, 4. Now here's the question. What if I'm f at 1.000000001? Hopefully, you'll come back and say, well, that's going to be 4. So what's happened is that I'm going to actually be on this 4 line all the way over until I actually get to 1. So all the points up to, but not including 1, are the ones I'm going to include. All the points up to, but not including 1. At x equals 1, I'm going to be down here. But once x is just past 1, then I'm going to go up here. And again, I'm going to indicate that with an open circle. And that'll help me go forward. There's a couple of other ways to solve this, but I've got several videos posted for that to do it a different way. So if this way doesn't work for you, try looking at the other videos and see if that helps you get going.